This video is over section 1.6, absolute value equations. And so typically we think of absolute value as distance from zero, but for this little box it says the distance between 2 points A and B on a number line is given by the absolute value of A minus B or the absolute value of B minus A. These will be equal because when we take the absolute value of that difference, we're going to end up with a positive value for both, and it's going to be the same value. So that is the distance between 2 points on a number line is the absolute value of their difference. For this first section, it says write out an absolute value expression that represents the distance between the given 2 points on a number line. So for this first one, if we are taking the absolute value of A minus B, like up here, we will have the absolute value of negative 10 minus 3, and that would be the absolute value of negative 13. And the absolute value of negative 13 would just be 13 because negative 13 is 13 steps from 0. And I just wanted to prove a point that if we did the absolute value of 3 minus negative 10, we would have the absolute value of 13 because that 3 minus negative would be 3 plus. And then that is also 13 steps from 0. So up here we kind of talked about it, but if you take the absolute value of B minus A or A minus B, you're going to get the same result. All right, for this next one, we have the square root of 3 and 4. If we want to find their distance, we're going to take the absolute value of the difference. So if we take the square root of 3 minus 4 with absolute value, we're going to get roughly negative 2.27 rounding. And that distance from 0 would just be 2.27. And then just to prove my point, if we do 4 minus the square root of 3 and the absolute value, we're going to get the absolute value of 2.27, which is 2.27. Now, if you're using a TI-84 calculator and you hit the math button, I believe if you scroll, you'll be able to find, to the num section. So a side note, I'll use orange. If you're on the TI-84 and you hit math and then you go to the right, it's going to be option 1 is absolute value. And you can use that on your main menu if you need. All right, for this next section, it says solve the absolute value in equations. And I do want to make a note here. When we're doing this, we need to isolate the absolute value first. So before we try to do anything, our first goal is to isolate the absolute value. So like on this first one, we want to get absolute value of r by itself. On the second one, we want to get the absolute value of x by itself. And then on that third one, we want to get the absolute value of y minus 4 by itself first. All right, let's go ahead and do it. If I have the absolute value of r minus 4 equals 12, I'm going to add 4 to both sides. And I'm going to be left with the absolute value of r is equal to 16. And what this is asking is which values of r are 16 steps from 0, or which values of r will give me positive 16 if I take the absolute value of them. So for here we have two solutions. We have r equals 16 or r is equal to negative 16. Both of those, when I plug them in here or here for that matter, I'm going to get the equation to be true. So we need to write this as a set. So if we write this as a set, we could write negative 16 comma 16, or if you wanted to be shorthand, we could write it as plus minus 16, and that still would be the same, just kind of shorthand. All right, for this middle problem, we have 3 absolute value of x minus 5 equals 10. I'm going to add 5 to both sides. And I'm left with 3 times the absolute value of x is equal to 15. Our goal is still to get this absolute value by itself. So I need to divide by 3 before I do that. And I'm left with the absolute value of x is equal to 5. So this is saying what values of x will give me 5 if I take the absolute value of them. And this one again has two answers, x equals negative 5 or x equals positive 5. And again, we can write that as just plus or minus 5 in our set brackets. If you want to write it twice, great. Both are fine. All right, last one, we have the absolute value of y minus 4 minus 2 is equal to 6. So to start, I'm going to add 2 to both sides, and that gives me the absolute value of y minus 4 is equal to 8. Now we have the absolute value bars by themselves. If you notice on the left side, that's all that's left. There's nothing outside of that. And so from here, we can split this into two problems. So here, y minus 4 is equal to 8, or y minus 4 is equal to negative 8. So that gives us our two answers. Now we're not done because we still need to find y. And so to get y for this first one, I'm going to add 4. And I get from my first solution that y equals 12. And then for the second one, I also need to add 4, but this time we're adding it to negative 8. And for my second solution, I get y equals negative 4. So if I write that as a set, that would be negative 4 comma 12. And I'm going to use orange because I'm going to erase it real quick. But if I were to plug either one of those into y, we're going to get 6 for the equation, which is what we want. So here really quick, if I did negative 4 minus 4, absolute value, minus 2 equals 6, I would have the absolute value of negative 8 minus 2 equals 6, which would give me 8 minus 2 is equal to 6. So that one works. And then if I did 12, I would have 12 minus 4 in the absolute value, minus 2 equals 6. This would be the absolute value of 8 minus 2 equals 6. And so I would have 8 minus 2 equals 6. Same answer. So this one does check out. All right, next section, same thing. Solve the absolute value equations. They're a little bit more complicated, but we're still trying to isolate these absolute value bars before we do anything else. So for this first one, if we need to get that 3 onto the other side of the equal sign, we are going to divide by 3. We don't want to distribute in because though 3 is positive, if you had a negative, it could really mess things up. So we don't want to distribute into an absolute value. So when I do that, I'm left with the absolute value of 5 minus 2t is equal to 10. And from here, we can split this into two problems. So we have 5 minus 2t is equal to 10, or 5 minus 2t is equal to negative 10. I'm going to try to write small, but when we solve this, we're going to subtract 5. And we are left with negative 2t is equal to 5. If I divide by negative 2, I get my first t is equal to negative 5 halves. If you really want to do decimals, negative 2.5 is fine. I don't think that the computer will care. All right, for the second one, we are going to subtract 5. And I'm going to get negative 2t is equal to negative 15. Divide by negative 2. And we're going to get t is equal to 15 over 2. So for this one, my solution set is negative 5 over 2 and positive 15 over 2. Both of those, when I plug in for this t here, will give me 30 for the whole equation. Or I guess the left side would equal 30. Okay, next problem. We have 4 equals the absolute value of 4x minus 4 plus 12. So first, let's move that 12. When I do that, I have negative 8 is equal to the absolute value of 4x minus 4. Now we can stop here. Come right, stop. And the reason why we can stop and say no solution is because you cannot have a negative distance. Let me write that down. So absolute value is considered distance. Absolute value is thus always positive. Here, this is saying that the absolute value of 4x minus 4, no matter what the x is negative 8. There's absolutely no way to take the absolute value of anything, no matter what x is, to get a negative 8 answer. So we can stop at this one and say no solution. Let me change that to blue, just for the sake of matching. This one is no solution. No value of x will make this right side equal to 4. All right, next one, solve the value equations with two absolute value equations. So these are handled a little bit differently, but for the most part the same. So here we're just It doesn't really matter, but we're going to split this into two problems where we take it equal to the positive and the negative. You can do either side. I'm just going to make this right side positive and then negative, but you're going to get the same answer if you make your left side positive and then negative. Just don't do them both, if that makes sense. So let's just go ahead and do that. So we have 5x minus 7 is equal to positive 3x plus 1, or we have 5x minus 7 is equal to negative all of it 3x plus 1. So our two answers are the positive version of the right side and the negative version of the right side. Again, you could do the left side with this, but yeah, you don't have to. I chose to do the right side. All right, so we're going to solve these. I'll go kind of quick because it should be pretty easy math from here. So I'm going to subtract 3x. And at the same time, I'm going to go ahead and add 7. These cancel and these cancel, so I've got 2x is equal to 8. And for my first solution, I have x equals 4. For the second problem, I'm going to go ahead and distribute the negative, and I've got negative 3x minus 1 here. I'm going to add 3x. And at the same time, I'm going to add 7. So again, these cancel and these cancel. I've got 8x is equal to positive 6. Divide by 8. And when I reduce that, I get 3/4. So for here, the solution set would be 3/4 and 4. I guess, or 4. Either one of those is going to work if we plug it in for x here and here. All right, last problem, we have 2x minus 1 is equal to 1 minus 2x. I'm going to take the left side, 2x minus 1 is equal to the positive of the right side, or 2x minus 1 to the left side is equal to the negative of the whole right side. So I have this negative that I'm going to distribute to the whole right side. All right, so if I do this left one first, I'm going to solve for x. I'm going to add 2x. And at the same time, I'm just going to add 1. These cancel and these cancel, so I've got 4x is equal to 2. Divide by 4, and I get x equals 1/2. For the second one, I'm going to distribute this negative to start. I have 2x minus 1 is equal to 1 plus 2x. Negative 1 plus 2x. And when I solve this, I'm going to add 1 to both sides, subtract 2x from both sides, and notice here that everything cancels out, so I'm left with 0 equals 0. So what this tells me is, I'm going to go ahead and write it out, but because 0 equals 0 is always true, so what that means is no matter what x is, 0 always equals 0. X doesn't even matter at all here. So because 0 equals 0 is always true, that means that any value of x will make 2x minus 1 absolute value equal to 1 minus 2x absolute value. So any value of x will be also true. So that's my solution set. I'll use blue, but my solution set for any number would be all real numbers. And really quick, let's just check that just so we can see. Now let's say I pick x equals 8. I'm going to have 2 times 8 minus 1. Absolute value is equal to the absolute value of 1 minus 2 times 8. And I've got 16 minus 1 is equal to 1 minus 16 absolute value. So here I'd have absolute value 15 is equal to absolute value of negative 15. And that's always going to be true. I just checked with a random number, but if you kept checking numbers, it's always going to check out.